When it comes to tin line operations, we have a lot of variables. The primary requirement for ocean NFPA are that we have a dedicated line that rescuers are attached to. The variables within that exist in this capacity. You can have a single line that is attached and dedicated to every single rescuer and can then convert as a dedicated retrieval system. One of the variables between rescue-based confined space and industry-side confined space is when we retrieve entrants. We're typically not just going to pull them out of the space without being able to, at a minimum, assess them and potentially package them. So the idea of a winching system that goes to a rescuer that's potentially out of sight and then just cranking him back are not very viable options for us as rescuers. Because of that, we've integrated some other variables into the tin line component. So your first option is to have a single line that goes to each rescuer and a tender dedicated to each of those lines. We're advocates of encouraging rescue personnel or tenders to run those lines through some form of a belay, even if it's something as simple as a munter hitch. We found that the discipline that's required to manipulate that tin line through a belay device requires them to be more diligent in their management of that line, so that if the rescuer loses communications with the outside, he has the ability to implement the rope tug system, and we can ensure with a lot more trustworthiness that that tender is going to feel those rope tugs, as opposed to if he's just feeding line into the space. We've found over the years that that results in a lot less diligence in minding that, and thusly a lot less communication between entrant and tender. So the application we're going to look at here that goes a step beyond that dedicated tin line is a gliding line. What this culminates in is a single belay line or tin line that runs to the primary rescuer. The secondary rescuer that's backing up that rescuer is going to take a prusik or a piece of webbing, girth it into his rescue harness, and then put a carabiner on the end of it. That carabiner is going to be clipped onto that same tin line. That gives him the ability to be on a dedicated line, but to also be able to navigate through that space independently of the primary rescuer. Both of them can glide and maneuver in the space as needed. If they need to communicate, they can both communicate, and then if we need to package them or rescue them, we'll be utilizing their line to access them, rig them, and then pull them out. One of the difficulties about using the glide line application is vertical entry. So when we're entering vertical, we like to use that tin line and apply it also as a belay line for the vertical application. For the primary rescuer, it's a no-brainer. It works just like we would typically operate a belay in a vertical entry. But once that primary rescuer gets down to the bottom, we want to make sure that he stays attached to that tin line. And the secondary rescuer is going to come up, and instead of clipping a glide point onto that belay, he's going to go ahead and put a prusik or some other fashion of progress capture device onto that belay tin line, and he's going to mind it while he's lowered into the space. Once he gets down to the base of operations where he's going to maneuver laterally, he's going to create a glide point, girthing that webbing or that prusik into his harness, clipping that glide hardware onto the tin line, and then remove his prusik from his person so that he can now freely be in a lateral gliding application. But it's important that you denote those two variables when doing a vertical inlet. So here's a lateral application with the glide line tin configuration. We've got the primary rescuer who's hard linked or hard lined to the tin line. The secondary rescuers on a glide point attached to that tin line. We also have communication line and air line umbilical. So these two segments are tethered together. Although the ResCon comm lines can double up as tin lines, in this application they're simply a life source umbilical for comm and air staying attached. Separate dedicated tin line for both rescuers. So in this application, we're utilizing the ResCom lines again with airline, but here the ResCom lines are functioning as the primary tin lines. Each tender is manually minding those lines as dedicated components for each individual rescuer. It's important when you make a tactical decision about what type of tin line operation you're going to implement. It is based on your logistical availability of manpower as well as resources. So if you're short on manpower initially, that's another application where the glide tin line is going to be very advantageous. The other issue with the dedicated tin lines is the propensity for entanglements. So as we continue to add components to the entry point, we continue to increase the likelihood of entanglement. The more lines in the space, the more opportunity for that to happen. The better we can streamline that operation, the less likely that is to happen.